Okay, so I'll describe the problem first. And I present a lot of different graphs in my class, and they are representative of a biological concept, and are kind of the foundation of, say, for example, population growth model, let's say exponential growth. There's a graph that they're really familiar with, that they've seen a lot, which is population growth on the y-axis and time over the x-axis. So they've seen this kind of graph in high school algebra or middle school, whenever they had algebra. But in my class, they are also being introduced to related graphs with similar variables, but slightly different, but that contain information that is relevant to the familiar graph of exponential growth through time. So, and this is the most complicated scenario, right? So what I see on exams, whether it's this particular set of graphs or a simpler graph, there's a subset of students that cannot read the graph. So they can't answer a simple question of like, at time point 50 along the x-axis, and say you have two different lines, and they're supposed to go at the time point 50 and tell the distance between line A and line B, and say this is about 15, a distance of like 15. And it's a multiple choice question, right? So the options are like 5%, 15%, 50%, and 90%, right? So there's enough, they're not needing to discriminate 20 from 24. There's a subset, a small subset that can't answer that question. And that's a very fundamental problem. Of those that can correctly answer that question, there's a subset that can't tell me why line A is decreasing, because they don't remember the biological concept that is represented in this graph. And then of the students that can do that, there's even fewer that can look at a graph of exponential growth through time and then answer questions about the other graphs that they had in class that are related to it. So despite having a lot of practice with the whole set of graphs. So there's a lot of levels of mistakes. And what I want to dissect is, what do they need to be able to do to successfully answer the hardest question, which is to see exponential growth through time, but answer a question about a different graph, that they're expected to remember what it looks like in their head. So I know there's a lot that I'm asking of them to get to that point. And what I want to figure out is, what are those steps that I'm forgetting?
What kind of things are those students doing, or what do they need? Like when you are trying to, like if we gave you a new problem, what is your thought process? What's the first thing you look at on your graph? We give you a new graph. Tara, tell us what's happening here.
Okay, I look at the axis labels and I see what variable is along the x-axis, what variable is along the y-axis, to orient myself. Because if I'm a student in my class and I'm seeing this on exam, I might remember that Tara said the axis labels might change. So I would orient myself to what the axis labels are. So what variable is being graphed against the other. Then they need to be able to recognize which model. Well, okay, they need to be able to recognize after they understand, after they've recognized what the variables are, they need to look at the graph, the line, recognize that this line is increasing. And what I need them to remember is that it's the exponential growth model. Like that's exponential, not logistic. It's really just differentiating between two different population growth models.
This picture or a second, there's two pictures.
Right. Imagine one is the S curve of logistic growth and one is the J curve of exponential growth. They're right next to each other, graph A, graph B. So the first thing I need them to do, is look at the axis labels, both the it's time on the X, population size on the Y, same labels on both graphs. I need them to recognize that the student needs to be able to recognize A is exponential growth, B is logistic growth. Then they go to the first question about these graphs. I'm realizing as I describe it, I'm asking.
The logistic graph, on the left side will also have exponential. Is there any chance that students are not? You see where I'm going with this? Or are they just looking and say, oh, both of those start the same? Even though you've told them one is this and one is this and identified. I'm wondering, like, trying to.
I think there's so many different mistakes that are being made, and I can kind of tell who's making what mistake by which answer they chose, which incorrect answer they chose. Sometimes they can see that population size is on the y-axis of the graph that's shown. So they can see that population size is increasing. So then they choose whatever option is describing the graph that's there, not remembering that the question's actually asking about something different. And there's also instructions right next to the graphs that say, I will ask you about a graph that is not shown.
Yeah.
So it's
tell me again, they do at first choose like exponential logistic.
I think most of them can identify that, but I also
goes well.
But then I think but the options sometimes trip them up, because some of the options will describe relationships that we've never seen. But then, oh my God, I'm realizing how fucking hard these questions are. I'm realizing how many steps, how many obstacles there are to them getting this question correct, even though they've had practice with like the same type of question. And they've graphed these graphs and they've learned it in class. So they've had a lot of experience with these models. But on an exam, it's almost as if they're expecting something harder than I'm actually asking. So they're making it harder than it really is. And so they're expecting something that they've never heard of before. And so they're choosing that answer because it's like, it looks like that's what right.
Like, we've seen this pattern. She said it'd be a new graph. Well, we've never seen this.
The strange thing is when this same set of questions was asked on a Canvas exam, when they were open notes, they didn't do any better. So even though they could go look at the three graphs that are related to each other, they still weren't getting the question right. So there's something that they still don't understand the relationships between, say, the three graphs that I've represented to them. And I think part of it is because they don't understand the biology.
So you're articulating this really well, and I'm going to stop asking questions after this, but I just want to help everyone to know sort of how to then follow up here, right? I think now one pathway to go anyway. is to say, okay, so then you just described several steps, and I just walked in through half of this. Several steps that the students have to go through to even look at and understand the question before they even get to the answering part. So then, one path to go down is to think about, okay, what are those explicit steps? And then how are they getting practice or scaffolds before they get to that? And now I'm gonna stop asking questions.
So
I have the first step and I have the second step, and then we went way off of my steps.
okay, so
You were
what,
doing the do, how would you do it?
okay,
Yeah.
so
I'm ready.
what's first and
I
second?
got first
you have?
labels
Then
and then
increasing
looking.
linear curve.
Yes.
Oh, first was, yeah,
Seeing the pattern.
Is
pattern
it-
recognition.
Yeah, you look at the labels, then you recognize the model or the type of graph, then you recognize the trend, which is recognizing the scale and recognizing the patterns. Then the requirement is to recognize exponential models. And then recognize that within there that there's a hidden scale on the, that's what I have all written down. So that there's a hidden scale. So you're gonna assume some type of scaling, like 1 or 0 to 100 or whatever. And then it said students don't need a scale. Then you need to remember terms associated to the graph. So like per capital, they need to recall that information in order to get to the graph and understand what is happening. And then orientation of the graph. So when I'm looking at the graph, I have to recall the orientation. And if I change the orientation, recognize that the orientation is different. And then I put recognize consistent, but I don't remember what that was about. And then recall the meaning of exponential growth again. And then you said on those two scales, would they see potential exponential growth on all of them and then get confused? Like this one is the J and then this one's the S, but in that S, they still have a J. And
But
maybe they're confused.
I'm going back to where she was explaining what she would do
Yeah.
versus what she needed her students to do.
That's what Tara said she needed to.
In other
That's
words,
her
if there
So I
steps.
think I stopped at step 2 because she went into the teaching side of it and what she wants her students the students have to do this. What do you do when you get to this? How are you solving it?
Okay, so can I pretend I'm my best student? I've looked at the axes. I've recognized that this is population growth through time. I'm seeing that the graph is a curve that is increasing. I remember that is exponential growth. I remember that in exponential growth, none of the variables that as in exponential growth, I remember that as population size increases, nothing is changing. I'm remembering that the birth rate stays the same, the death rate stays the same, and therefore the overall net per capita growth rate doesn't change. I also remember that is true because this is optimal conditions. Nothing is limiting the growth, so they can just grow and grow and grow forever because they have infinite food and infinite space. So then I look at the first question and it says in graph A is representing a population that A as population size increases, per capita growth rate decreases. And I'm like, no, per capita growth rate doesn't change. So that I'm ruling that one out. The next one says, as population size increases, per capita growth rate is increasing. I'm like, no, again, it's not changing. So I'm ruling that one out. Answer C says, as population size increases, birth and death rates remain constant. I'm like, right, yeah, no, nothing changes, birth and death rates stay the same. So this is probably the correct answer. Option D, graph A is representing a population size is decreasing with time. This is a distractor Option, because clearly population size is increasing through time. That's what I see in graph A. Option E is none of the above. And I'm smart enough to say that answer C was correct, and I choose that answer. And then the next question has the exact same options, but is asking about graph B.